Ivaco Rolling Mills is the Canadian steelmaking and rod rolling arm of Ivaco Incorporated.
It is located on the Ottawa River next to the village of Lorignal near Hawkesbury, Ontario, and employs over 417 people.
People who have been producing quality wire rod since 1971. Wire rod production begins with the steelmaking process. Many different types of steel scrap, along with various forms of direct reduced iron, are combined in computer-generated proportions to feed the electric arc furnace. This computer program, largely developed in-house, optimizes the quantities of each type of scrap used to make a heat of steel, in order to make the desired chemistry of steel while minimizing energy consumption and yield loss and maximizing productivity. The modern electric arc furnace is designed for efficient melting of the raw materials. The furnace controls and features have been upgraded to allow the steel plant to melt more steel in one furnace than it used to produce with two. Modern electronic controls and sophisticated water cooling allows power input as high as 38 megawatts to melt steel at the rate of almost 2 tons per minute. Molten steel tapped from the arc furnace is transferred to a sophisticated computer-controlled ladle metallurgy furnace. Energy is added to adjust the bath temperature while the steel is stirred using argon gas. An automated system adds the necessary quantities of various alloying elements to achieve the desired final chemistry. From the ladle furnace, the steel is transferred to a 4-strand continuous casting machine. The machine is equipped with dual-power electromagnetic stirrers to ensure uniform chemistry and solidification during the casting process. The highly sophisticated equipment and automation employed at each stage of the steelmaking process allows the accurate production of almost 200 different grades of steel. Product development metallurgists are continuously developing new grades of steel to satisfy the changing needs of our rod customers. Ivaco Rolling Mills has undergone a radical upgrade of its rolling facilities to meet the quality demands of a diverse customer base with increasingly sophisticated product requirements. The rolling process is fully computer-controlled. A new operator's pulpit was commissioned that involved combining the functions of the billets being charged into the reheat furnace, along with the operation of the reheat furnace. This state-of-the-art control pulpit allows the operator to control these critical processes, ensuring that the billets charged are of the correct chemistry, and that they are heated correctly prior to rolling. Through the use of locally mounted cameras, he has a full view of the entire operation that is under his control. Further, monitors of the production scheduling, rolling, coil handling, and packaging operations are at his desk that enables him to be in touch with all phases of the process. The main mill operator has video or direct visual contact with the entire mill, from billets entering the furnace to coils leaving the finishing end. Several computer screens allow him to control or monitor all aspects of the rolling process, from the furnace, through the rolling stands, to controlled water and air cooling of the rod, to coil formation. In normal operation, however, the mill scheduling system informs the mill what product is being rolled, and the process computers automatically adjust all rolling parameters, from furnace temperatures to rolling speeds, to cooling water flows, to conveyor speeds and cover positions.
Billets from our steel plant and other external suppliers are charged into a new computerized walking beam furnace designed and built by Daniele Centro Combustion of Italy.
The furnace capacity is 175 metric tons per hour on a 160 millimeter billet section. It is one of the largest billet reheat furnaces in the world and is designed to maximize heat recovery for energy efficiency. The furnace is equipped with 8 control zones for optimal management of billet temperature and furnace atmosphere. Hot billets from the furnace are transferred to the entry of a single-strand, 4-stand, high-speed housing-less stand breakdown mill. These 4 stands produce a 105 millimeter round from a 160 millimeter billet. The round bar is fed through a crop and cobble shear to a 2-strand free bar covered roller table. The roller table delivers the bar to stand 2 of the original roughing mill. During the final phase of our upgrade, reducing sizing mills were installed along with the new water box temperature control systems. These enable accurately controlled temperature rolling to be performed, enhancing the grain size control of the finished steel rod. This system uses feed-forward control that minimizes the length of uncooled ends and maximizes rod temperature control and uniformity. Ivaco Rolling Mills' entire rod is now being produced with the reducing sizing mills in place. An improved size tolerance of plus and minus 0.004 inches, that is 1/4 standard on the diameter, is now obtained throughout the entire coil length. This has been accomplished by the use of dynamic parting that precisely measures the gap between the rolls that ultimately determines the rod dimensions. Customer-driven improvements with regards to ovality, tensile properties, die life, drawing speeds, scale uniformity and thickness, as well as grain size control, have been significant. The surface quality of the rod is measured using an online eddy current surface detection unit, with the defects being registered in our inspection department. If there are any quality concerns, the production is stopped immediately, and the corrections performed to ensure that the rod produced is of the highest quality.
In 2011, a new state-of-the-art $2 million surface detection unit was installed as part of a capital expenditure project to further ensure the rod quality.
The rod is then coiled in the upgraded high-speed laying heads and placed on the new Stellmore conveyors for final cooling. These conveyors incorporate all of the latest technology to achieve consistent, uniform, controlled cooling rates. These features include high-capacity variable speed fans for air cooling, automatic control of conveyor covers, and a succession of conveyor steps to ensure even ring cooling. The conveyors equal the best in operation in North America today. The cooled rings are reformed into a coil on Morgan 2-arm mandrels. These mandrels rotate the coils to a horizontal position to allow them to be placed on the new Sunco H hook conveyor system, designed and built by Sunbursta of Sweden. This system will handle the full 6,000-pound coils produced from the billets, equal to the largest available in North America.
As part of the rod mill upgrade, a new Sunco H compactor was started up to ensure adequate compacting and tying capability for the new mill. The profile of the compacted coil from this machine has resulted in a quality package that has enabled our customers ease of payoff and fewer handling issues of these coils. As a result of these customer-driven benefits, a second Sunco H compactor was installed. Over the years, the mill output has increased dramatically in quality. The mill has grown to one that produces 80% of its output in premium products, such as cold-heading steels, high-carbon steels, welding steels, industrial steels, and others. Ivaco Rolling Mills is now one of the largest and most advanced mills in North America, devoted exclusively to the production of hot-rolled wire rods.